we looked at that one there. So now we should be able to find sum to infinity given sufficient information. Okay, given sufficient information. And what is that sufficient information? You should be able to find the, you should be able to find, you should be able to have the first term and the common ratio, all those things. That's when you'll be able to find, that's when you'll be able to find the sum to infinity. Right. Okay, but before we can look into the main details of sum to infinity, I want us to have a recap on the previous lesson. Remember last time we looked at the sum of a geometric progression, and I gave you those two questions. You remember them, not so? Are you able to remember those questions I gave you last time?
Yes.
Good. All right, so we are going to do a recap. Remember, I gave you this question here, which said, find the first three terms of the GP of which the common ratio is negative 2/3, and the sum of the first 6 terms is 133. Okay. All right. So now, I gave you this problem. Most of you couldn't get it right, so we are going to solve it together. So how do you solve this problem? So remember, you have the common ratio there. The common ratio has been given to you. That is -2/3. And the sum of the first 6 terms has been given. That is 133. All right. And then the number of terms we are considering in this case is 6. All right. So this is the data that you needed to have in order for you to solve the problem. And then the formula to use was supposed to be that one there. Sum of any terms is equal to first term. You can see the numerator, the first term, open bracket 1 minus common ratio to the power n. So this formula is convenient if the magnitude of the common ratio is less than 1. And when you look at the common ratio, it is less than 1, -2/3. You can see it there. It is less than 1. So this formula is convenient. Now, if it is greater than 1, then that's where now you see something like the power to the, r to the power n is usually the first. It takes the place of 1 there. So in this case, this is what we are going to use. That is the one that is going to be convenient. So now what are we going to do from there? The next thing now is to substitute in there. Okay. Substitution is going to take place. So now when you substitute, you will find that it is going to appear something like this. So some of the first any terms we are going to have 133, and then the first term, the one we are looking for, you can see it is showing there, just the letter A. And the common ratio we have substituted there, -2/3 to the power 6, because that is n there, over 1 minus -2/3. So these are substitutions in the formula that we are considering. All right. So from there, we now start working out this stage by stage. So what is going to happen is we are going to find the value of -2/3 to the power 6. And when we find the value of this, you can see in the next phase here, we're having -64/729. So we have this situation here. And then when we work out the denominator here, when we work out this part, 1 minus negative 2 over 3. You're going to end up having 5 over 3 like that. From there now, you are going to multiply here. You are going to multiply the first term by the value of what you get in the brackets here. When you solve what is inside the brackets, you are going to get this expression here. When you work it out with your calculator, you have a calculator with you, I'm sure you can solve this problem here. You find that to give you 665, and when you multiply 665 by A, it will give you 665A over 729. Now, what will happen here, I'm sure you are able to see the multiplication sign that is here. You know what happened is, you know, whenever you're dividing fractions, the division sign changes to multiplication, and then the divisor is usually inverted. That's why you can see the 5 over 3 is changing to 3 over 5. Okay, it's changing to 3 over 5. And then when you do your multiplication correctly, it is coming to this stage here. I'm sure you can see that. And then after this step, you have to cross multiply this part here. When you cross multiply, you are going to have something like this. Remember the 133, when it is multiplied by the 233, it will show this part. And then when the A goes the other side, it will show something like this. I'm sure you can see that. And then when you work out the value of A, it will give you the 243 here. It will give you 243. And then 243 is the first term. Okay, 243 is the first term. Now, how do you find the rest of the terms? Remember, whenever you're finding terms in a GP, you have to multiply each term by the common ratio, because that is the constant ratio. And we remember the common ratio, we found that it was negative 2 over 3. So each term that you get, multiplied by negative 2 over 3 to get the next term. So 243 multiplied by negative 2 over 3, you are going to get negative 162 here. And then when you multiply by the negative 230, again, you are going to get 108. So basically, these are the first 3 terms which I was expecting from you. Remember, I asked you this last time. So this is a recap. So that was the first question. The second question was, find the sum of the first 10 terms of the GP. Find the sum of the first 10 terms of the GP. And the GP was 3, 12, and 48, and so on. Remember, the 3 dots here means and so on. So meaning we have many other terms that are following after this. So this is an infinite GP. It's an example of an infinite GP because the number of terms is not terminating. We have included even those that we have not shown. That's what this means. Okay, so find the sum of the first 10 terms of the GP. So what do you do here? Whenever you're finding the sum of any terms that you are given, make sure you establish the first term and the common ratio. So here you find that the first term is 3, as you can see there. Then the common ratio, remember, to find the common ratio, you have to divide the next term by the previous term. So the next term here is 12, the previous term is 3. So 12 divided by 3, it will give you 4 here. Okay, it will give you 4. And then the sum that we want to find is the sum of any terms. 10 terms here. So where it is written n, we are going to put 10. And sum of the first 10 terms, that's what we are looking for. That is why it is in question mark. So what do we do there now? So since we know that the common ratio is greater than 1, as you can see, it's greater than 1. So the most convenient formula is this one here, where this time around r to the power n is appearing first. Remember, in the previous example, the previous work that we are doing, 1 was the one that taking the place of this part here. Now it is the opposite. Why? Because the magnitude of the common ratio is greater than 1. So this is the convenient formula. So what we are going to do now is to substitute what ought to be substituted. Okay, and when we carry out our substitutions correctly, it is going to show something like this. Remember, n is 10, so there it is. And the first term is A, So there it is there as well. And then 4 to the power 10, because that is n minus 1 over 4. That is the common ratio, 4 minus 1. So when we work out this part, you find that 4 to the power 10 will give us this figure here. You've got calculators, you can try it out. It will give us this figure. And remember, we have the first term 3 here, it's appearing. And then minus 1 over 3. Where is the 3 coming from? Remember, 4 minus 1 is equal to 3. Hence, the 3 that is here. So now what is going to happen here? We have to subtract the 1 from this figure here. This figure is actually 1,048,576. And when you subtract the 1, I'm sure it's just a 5 that is going to appear. The rest of the figures will maintain. And then we divide by 3. And these can cancel here. For any information, the 3 and the 3 can divide. So meaning that we're just going to have obviously a 1,048,575. That is what is going to appear here. I'm sure this is making sense to you. Is it making sense, boys and girls? Let me hear from you.
Yes, sir.
All right, that is good. I'm sure that is a shepherd's voice I can hear, and I can see him there. All right, so this is what I expected you to give me as answers last time when we looked at the sum of a GP. So now today we are looking at the sum to infinity of a geometric progression. That's what we are looking at. Now the question is, what is sum to infinity? So we are saying to say any progression that has an infinite number of terms, we say it is an infinite progression. Infinity, the word infinity means something has no end. It is not terminating, it is just continuing. So a geometric progression that has no, where the terms are not terminating, we call it an infinite progression. So now, under certain circumstances, it is possible to calculate the sum to infinity of a geometric progression under certain circumstances. Now, what are those circumstances? The sum to infinity of a GP with the first term A and the common ratio is given by this formula. This is a formula that we use whenever we are finding the sum to infinity of a geometric progression. So we read this one as sum to infinity. This is a symbol for infinity. It looks like an 8 that has been dropped, like you can see it there. So this is a symbol for sum to infinity. Sum to infinity is equal to first term over 1 minus r, the common ratio. All right, where A is the first term and R is the common ratio. Now, there's something unique about the common ratio. Remember, we said sum to infinity of a GP is only possible if the common ratio is meeting the situation, and that is -1 must be less than the common ratio, and the common ratio must be less than 1. Those are the conditions, because we call that one a convergent GP. All right, so that is sum to infinity there. All right, so we are going to look into the examples, and the first one is as follows. Find the sum to infinity of this GP.
That's okay.
Is that supposed to be a question? I can hear some noise in there. Is that a question?
Proceed. You're saying proceed.
Okay, all right. I can't even get you correct because there is some technical issues going on. All right, so find the sum to infinity of this GP, where the first term is 1, the second term is -2/3, third term is 4/9, and the fourth term is -8/27. So we are going to find the sum to infinity of this GP. So now, we can say that the first term is 1. The first term is 1. The common ratio has to be calculated for, as you can see. So to find the common ratio, we have to get the second term, divide by the first term. The second term, as you can see, it's -2/3 there. As you can see, divide by divide by 1. So this is negative 2/3 divided by 1. So when you divide these two, it will give us negative 2/3 itself. Why? Because remember, I've always told you to say any number, any term, anything that you divide by 1 is the thing itself, is the term itself, is the number itself. So I'm sure this is not a surprise. So negative 2/3 divided by 1 is negative 2/3 itself, as you can see there. All right. So we have our common ratio. So now we can go on and find our sum to infinity of this GP. So it is just a matter of substituting the data that we have collected here. So where it is written A, we are going to substitute with a 1, as you can see, that is what is there. And where it is R, we are going to put negative 2/3. Just be careful. Remember, we have a minus sign here from the expression. So when substituting R, make sure that it also carries the negative sign here. Is this making sense, boys and girls?
Yes.
Okay. So when you do your substitutions correctly, you are going to get something like you can see here. So sum to infinity is equal to 1, the first term there, as you can see, over 1 minus negative 2/3. So negative 2/3 is the common ratio here. Okay. Is the common ratio. Now equals 1 over. So when we work out this part, remember we've always said to say brackets in mathematics denote a multiplication sign. So we are going to multiply negative by negative there. It will give us a positive, and that is the positive we are able to see there. So 1 plus 2/3 here. 1 plus 2/3. Remember, whenever you're adding something like this, when you're adding a whole number and a fraction, even subtraction, there's an easy way of carrying out your work. Rather than finding the common denominator, I'm sure you are thinking of finding the common denominator here. That is obviously 1 over 1. And then when you find the LCM, that is 3. And then you do those other things. But there's an easy way of doing your work here. And that is what I'm going to explain here. Now, what do you do here? What you do, first of all, you must know that there is a 1 as a numerator to this entire fraction here. 1 is the numerator. So you multiply these 3, the denominator, by the whole number 1. When you multiply 3 by 1, what is the 1 times 3? What is 1 times 3? Who can give me the answer? Yes, that hand at the back, the first hand there. Can you give me the answer? No, that one who is wearing, I don't know. There's something that you have put on your head. I can't see you clearly. There is the quality of the video is not okay. Okay, can anyone give me the answer? What is 1 times 3? Okay, thank you. It is 3. So 1 times 3 is 3. So that 3 that you have obtained. So 1 times 3 is 3. So that 3, add it to 2. Okay, so that 3 plus 2, it will give you 5. And this is the 5 over the same 3. You have to maintain the denominator. Okay, so you are getting 5 over 3 here. So that is how you quickly add these fractions here. So it will give you 5 over 3. And then the 1 must maintain that is on top. Remember, 1 is the first term. Now, what should follow after this? Remember, this over here is a division sign actually. So when you carry out your division process correctly, you must find that it will give you 3 over 5, as you can see here. So this is our sum to infinity. This is our sum to infinity. You can just manipulate if you want to say 1 divided by 3 over 5, and then the division changes to multiplication, and then you invert the divisor. The 5 over 3 becomes 3 over 5. And when you carry out your multiplication, it must give you this. I'm sure this is not something that will be so hard for you to handle. Okay, so this is the sum to infinity. This is the first example. Now I've got another example that I want to solve with you. All right, so this is our sum to infinity. Sum to infinity, this is another example. Sum to infinity of a GP is 6. It is given. If the first term is 2, find the common ratio. Find the common ratio. So the sum to infinity formula is given as follows, as you can see. where sum to infinity has been given to us that it is 6, and the first term is 2. As you can see, that's the first term, and then sum to infinity is 6. Okay, sum to infinity is 6. So we are saying when you substitute now, when you do a substitution, where it is written sum to infinity, you're going to put 6 there, equals where it is first term A, you put 2 over 1 minus R, the common ratio. Okay. And remember, what we are finding is the common ratio in this case. That's what the question is telling us. Find the common ratio, as you can see here. So in this expression, we are going to solve for R. So how are we going to do it? If you cross multiply, you find that the 6 will multiply by the 1 minus R, which is here. Okay, so this is how it is going to be. So this will multiply by this to give us this. And then 2 will multiply by 1 if we are to put 1 here. So it will appear something like this when you carry out your first multiplication process, the cross multiplication process. So now you can even subdivide again. You can subdivide this 6, you subdivide it on both sides of the equation. The 6 will come this side, as you can see. And then here we're just going to have 1 minus R. Okay, that's what we are going to have. And then you can even simplify this if you want, because this is a simplifiable fraction where 2 is the HCF. And when you simplify correctly, you are going to have 1 over 3. So what will happen is that since you are looking for R, you are going to take this 1 to the other side of the equation. And when it comes to the other side of the equation, it will be -1. And negative R will maintain here. And this one would have been simplified to become 1/3, as you can see. So negative R is equal to 1/3 minus 1. Then negative R equals, when you work out this part, when you work it out correctly, it will give you -2/3, as you can see. This is what it will give you. So now, since what we are looking for is the positive R and not negative R, so you're going to subdivide on both sides of the equation by -1, it will give you just 2/3. Hence, the common ratio that they have asked us to find is 2 over 3. 2 over 3. So that is the solution to this other example. I'm sure it is understood there. Now, in case you have not understood, I have intentionally put a video on a slide for you to watch. So you are going to watch a video down there for you to understand further in case you missed something here. So that is the video for you.
So we are unable to get the sound.
Oh, you're unable to get the sound. You are unable to hear the sound of the video. Hello, Mr. Mombasa.
No, sir. I'm saying we are unable to get the sound of the video.
Is it? But I can hear the sound from here. I don't know if it's yours to do something that side. I don't know. Is there anything I'm supposed to do here for me to let the sound be heard that side?
From that far end?
Yes.
No, definitely no idea. I don't know how the video was recorded. So.
Okay, but the sound is, I can hear the sound perfectly well from here. Okay, anyway, I'm sure it's understood, boys and girls. Have you understood? I can hear Shepard just nodding his head there. Then I can take you into the exercise. Because looking at time, I'm sure we have limited time.
Sir,
There's a question here.
Yes, please.
like number two, the exam number 2. You can just repeat.
The second example, he hasn't understood anything.
The second example.
Yes, sir.
You mean this one?
Yes.
Where exactly?
Just that one.
Sorry?
That's on the top.
There is poor quality of the sound, so I can't hear you properly. If you may, I think, try to speak up.
Just that on the top. How you started explaining.
I can't hear you properly. Anyway, let me just, I don't know if I have to re-explain this.
It's saying, starting from the top there, you can't understand which is lost or something.
All right, okay, let me repeat then. So we are saying the sum to infinity of a GP is 6. The sum to infinity of a GP is 6. If the first term is to find the common ratio. So, you know, what we are trying to do, boys and girls, here is, you know, questions can come in different ways during exams. Sometimes they can ask you to calculate sum to infinity when you have been given a GP. Okay. Sometimes they can ask you to calculate the sum to infinity given a GP. Sometimes you will be given sum to infinity. Maybe one of these is missing, either the first term or the common ratio. So all you just need to have is the skill of changing subject to the formula. And that is a concept I believe by now you must have. It's a must be in grade 12. Okay. In grade 9, there's a topic that talks about changing subject to the formula. And I'm sure along the way, we've done quite a number of calculations which involve changing subject to the formula. This is not something I am expecting you to struggle with. So it's a situation where we are saying to say a GP as the sum to infinity has been given here. Sum to infinity has been given that it is 6. Okay, here sum to infinity is 6, and the first term is 2. Okay, so in this entire equation here, we have been given sum to infinity and the first term. I'm sure you can see the cursor here. Can you see it? Can I quickly receive feedback, please? Can you see the cursor moving here? Hello? Okay. I hope I have to continue. So this is the first term and that is the sum to infinity. So it's just a matter of substituting. Where there is sum to infinity here, just put 6. Okay. And where it is 2, the first term, you just put 2 there. You just replace it there. Okay. You just replace. And then you solve this problem. You just solve this problem. How do you solve it? You are just solving for R. In this equation, you're just solving for R. Okay. This is what you're solving for now. How are you going to solve for this? So you imagine this is over 1. The 6 here is over 1 so that it becomes a fractional equation. Then you cross multiply. And in your cross multiplying process, I'm sure you know that the 6 has to be multiplied by the 1 minus R. And this is what I've shown here using brackets. I've shown that I'm going to multiply 6 by the expression 1 minus R. And then there is a denominator 1 to this fraction. The 1 is going to multiply by 6. So the 1 that is invisibly here, you multiply it by 2, it will give you the 2 that is here. So basically from this stage, this is the stage that should follow here. 6 multiplied by this expression equals 2. And when you multiply correctly, you can do it the way you want. If you want, you can distribute the 6 over subtraction. That's a 6 times 1, you get 6, and then 6 times r, you get 6r, and then you proceed. Okay, you proceed there. Or you can subdivide both sides of the equation by 6, meaning this side, maybe this is why you're missing, you're missing it from. You divide both sides of the equation by 6. Okay, you drop a 6 here, even this side you drop a 6, just that I did not technically show it here. Okay, maybe that's why you're missing it out. But otherwise, this is something that I believe you can do even from here, just substituting. I believe you can continue from here up until the last stage here. There are many ways that you can manipulate a mathematical expression. So this is how I felt I can best do it. That's why I'm saying, that's why you're seeing me doing it this way. So I am assuming the 6 is divided on both sides, and that's why it is showing here. And then the 1 minus r is just remaining here. That's why I'm seeing it here. Okay. And then from here, you can simplify the fraction here, the 2 over 6, you use the HCF 2. 2 into 2, you find that to give you 1. And that is the 1. And then 2 into 6, it is 3 here. Okay, it is 3. Again, from here, the 1 can move from this side of the equation. It can come this side. And when it comes this side, it will change the sign from positive to negative. That's why you can see it negative here. Okay, so negative r is equal to 1/3 minus 1. Okay, 1/3 minus 1. And when you work it out properly here, it is going to give you 2/3. Okay, it's going to give you 2 over 3. Of course, negative. Okay, when you work it out from here. Remember, you just say 3 times 1, it's going to give you negative 3. And then 1 minus 3 is going to give you negative 2. And that's the negative 2 over 3 here. Okay. Now from here, since what we are looking for is it's positive r. So we have to get rid of the negative sign here. And how do we get rid of it? It is by subdividing on both sides of the equation. So you just imagine this over here. So you say this negative r here, you say divide by negative 1, because there's a coefficient negative 1 here. So you divide by negative 1 this side, even here by negative 1. So eventually you are going to have a positive 2/3 that is going to show here. Okay, that's why I wanted you to view that video so that where you are lagging behind, you can see from the video that side. And unfortunately, you can't hear the sound. I don't know, for some reason. Otherwise, this is how best I feel I can explain this to you. I don't know if it's understood.
Yes, sir.
Is it understood?
Yes.
Okay, I can hear Bill's voice there. Okay, if it's understood, I want you to try out. We are going to skip the video since it's not giving you sound there. So we are going to go into the questions for exercise. The first one says, find some to infinity of the following GPs. So what you are going to do, I will just need you to copy these questions because we are running out of time. I'm sure the next one will need to come in. So these are the questions I want you to try out. Find the sum to infinity of the following GPs. There's this first one here. You find sum to infinity of this one, and then you find sum to infinity of this one. And then the other one says, in the second question, find sum to infinity of the sum to infinity of a GP is 64, and its constant ratio is 3/4, or 3/4. Find the value of the first term. Remember, the letter A in a geometrical progression, it means the first term. So you're going to find the first term there. And then the second one says, find the value of V. So you read this one as sum of the first 6 terms correct to 3 decimal places.